Hello, everyone, and welcome to another Into the Terminal. Today, Nate, welcome back from family time, is going to be walking us through a new feature of RHEL called Image Mode, which is based on the open source project Bootsy. So,
Yep.
Nate, tell us a little bit about Image Mode. Like, why bother?
So I have to say I love this feature only because of the doors that it opens, right? Um I don't want to like wax too poetic here, but since like since the dawn of public clouds, we've been promised this idea of these systems we don't have to care about. We just provision and run and replace and whatever, right? And making that work on a standard package mode Linux system has been a little challenging. A lot of organizations never really got there, right? Some people think they're there, they're not quite. Some people really put in the time and they're there, but image mode makes it so much easier. And that's kind of what I wanted to demonstrate today, right?
Cool. Well, while we jump into the terminal, don't forget to mash that like and subscribe button so that we can keep doing what we do. Nate.
Right. So we are at the console of a VM that's running in our lab environment, and it's an image mode RHEL 10 system. And I've got it booted up. And let's just say, for the sake of setting up our scenario here, let's just say this is a production web server. And we've had our web developers tell us there's an update ready for this machine. Let's say, they changed the Apache config or they've updated the site, whatever, right? Something that's going to get deployed to this machine is ready to be deployed. In the past, what that would usually mean is we got to copy a bunch of code up to this machine, make sure that it works, or make the configuration changes manually or with some sort of automation, and then test and make sure everything's cool. And if it doesn't work, then we got to go into troubleshooting mode. So what we're going to do here is with an image mode system, and let me refresh the screen here. There's this command line tool called Bootsy. And what we're going to do, and we'll go into how all this works in the deeper dive, but what we're going to do is we're going to tell this system, hey, let's see if there's an update available for this machine. Okay, so we're just going to say, don't pull it yet, just tell me, is there an update available? And if I got my lab provision right, we should have one. Yes, there we go. So it's telling us right here, there's a new version available, right? It's version 10.0, surprise. And it gives us a digest and whatever. And this should feel a whole lot like what the sort of data you might get out of a container, because it kind of is. Now we're going to say, okay, we've got an update ready. Let's go ahead and apply that update. And it's going to pull down the layers of that container image that have changed between what's running on my machine and what's in the new image, right?
Out of curiosity,
do that here.
What are you running on this machine?
This is a RHEL 10 image mode box.
So what you're running currently is also RHEL 10.
Yes. Yeah. So I'm pulling in RHEL 10. We can talk a little more about what Scott might be trying to allude to there later, but
just curious.
Okay. Just curious. So you can see it pulled in a decent chunk of layers there. Now it's deploying them. And while it's deploying them here, what it's actually doing is it's writing down a file system. It's actually writing the contents of that container image to the file system of this machine, right? And it does it in a tree fashion so that we can enable the thing I'm going to show you next. So now we've got the new system or the new update staged. We're just going to reboot the machine. And of course, rebooting could take a couple seconds. Go ahead, Scott.
In the other demos that I've seen on this, they've used a command called, I think it's Bootsy status. So they actually see the multiple images that you've got and which one is active or not active.
Yes. Yeah, we'll show you that in the deeper dive.
Okay. And in our episode, like thumbnail, we said something quirky like update Linux like your smartphone.
Yeah.
Why did we choose to say that?
So if you've ever updated, honestly, it's both major smartphone vendors at this point, both Android and Apple. They use a very similar mechanism where it downloads an image of the base operating system, and it applies that in this tree fashion, the same way that we are now. And then all it does when the update is finished and it reboots the phone, it's just switching to the other tree. And if something goes wrong, it automatically will switch you back, right, on your phone. That is. This doesn't automatically switch back, but we'll show you what you can do if there is failure. So let me get logged back in here. Our really secure password. Now, you'll notice that at this, all I did was log in, and immediately it's telling me there's a failed unit. Something's wrong, and httpd.service is the thing that's failed. Now, you might say, well, this is a different way to run a RHEL system. How do I troubleshoot it? Well, the cool thing is you troubleshoot it very similarly, or maybe even identically, to how you would a standard package mode RHEL system. So we're going to check the status of HTTPD, and guess what? It is in fact failed. Now, we could start delving into why it's failed and whatnot, but remember what I said. Imagine this is a production web server, right? Maybe we're in a maintenance window. Maybe we have time to troubleshoot. Maybe we don't. The point is, with image mode, you don't have to sit here and take the time to troubleshoot. All you have to do is roll back. So we're going to clear the screen again here. We're going to do Bootsy rollback, because we are losing super businessy business. Did I typo something there? Initializing. Oh, sudo. Forgot sudo. Okay, now what this is going to do is it's going to basically just tell the system, hey, the thing we were just on, go back to that. And then we're just going to reboot again. And of course, we have to wait for the thing to reboot, which is relatively quick because it's just a virtual machine. But what this should be doing is at the next boot, it's going to tell the bootloader, boot the last known good tree instead of the tree we just applied, right? And what it should do is once it comes back up, it should be on that old version of the image, and we should be back up and running again. It's already back up. All right, and you can see there's no more error about HTTPD not being started. And sure enough, it's up and running now. So there you go. Pretty simple, right? I like it. I think it's pretty cool.
So like, for those of you who may not have observed what exactly just happened here, we needed to update the operating system and or application.
Right.
On a new image, which pulled down to the system. You can stage that in advance. Then we booted into it. During our validation checking, there was some kind of weirdness. And to roll back, we simply ran a command and rebooted, and we were back in our initial state. And that is really, really huge, because if you've worked in Linux for a while, you may be more familiar with managing packages, where you do like a DNF update, HTTPD, or whatever packages you have. And if there's a problem after you've applied those updates, you now get to figure out which packages caused the problem, any additional meta weirdness like scripting or whatever else, and how to potentially try to revert those changes back so you can get back to where you started, which was a known good working state. And with image mode, all we did was revert the image and reboot the machine. Boom, back to a known good working image.
Yeah. And I think that's what makes it so exciting for me, right? And the other thing to think about is, say you have a system, and I know this isn't a common use case, but imagine in like a high performance computing situation or something where you've got nodes that are maybe deployed for specific workloads. In the past, you had to have like these weird virtual environments to make that happen. You could literally make an image and redeploy a whole node with specifically tailored for the workload you want it to run for the next 3 days. And then when it's done, just deploy a different image to it. I think that's pretty awesome. I think that's pretty amazing.
All right. So in the deeper dive, Nate, what are we going to cover?
So we're going to cover more image mode. Surprise, right? We're going to actually show you how you apply updates and update your container image, your Bootsy image. We're going to show you how to check the status of Bootsy, so you can see, are there updates? What's the status of my system? Is there a rollback available? That kind of thing. And then, yeah, if we have time, we could even talk a little bit more about maybe how to integrate this into CI/CD workflows so that you're not building these things manually, which is exactly how I'm going to display them.
Yeah, and I think the other thing is realize like all the magic that we just showed you requires a commitment to a different methodology for building and deploying and managing things. So you're not going to be using Kickstart. You're not going to be using DNF to do updates anymore. You're now like committed to managing things through images. So it'll require, if you're interested in doing this, some changes in your tooling and your thoughts of management and operations in order to pull through. But it may just be worth it because that was super hella cool. Just reverting back to the old image and being good to go so that you're not exceeding your maintenance window and like can go back to testing and like making sure what was happening or fixing it without having just sitting there with your super businessy website down losing money.
Right.
All right. So we will be back in just a couple of seconds and then we will do the deeper dive. All right. So Nate, tell us about image mode.
Yeah. So you touched on that that whole sort of new lifestyle or new methodology of managing your RHEL systems, and I remember back when I was starting to learn about containers and how I had to wrap my brain around how this is different, right? How is a container different than a virtual machine? How is a container different than the way that I've run workloads on Linux for, pretty much my entire career, which at that point was a good 15 years of, manual systems administration, moving into automation, and now all of a sudden this container thing. Well, basically you have to take those paradigms where changes don't happen in your containers anymore. They happen in your container file or your Docker file. And then they go to the registry and then they get pulled into production. You have to take that methodology and apply it to how you're managing servers, right? So you could log into an image mode system and do a DNF update, but you should not. Because that operating system or the disk layout and the files and the packages that are installed are pretty much an immutable file system tree, minus a couple of exceptions. So like Etsy, for example, that is where machine state is held and that's where configuration is held. And while you can modify that with inside of that container file, it's like a merged situation where if there's local changes, they will take precedence, right? And var. var is basically where all of the variable data for your system lives. So things like your website content or the data that your database depends on. So that does not get overwritten when you deploy an updated image. So these are just things that you have to think about, right? You have to learn how to work with them and figure out what's in that immutable part of the tree and what's not.
Yeah, and now is the place where if you're a live viewer, please put questions in the chat. If you're a deferred viewer, leave us a comment. We're pretty good about reading them and getting back to people. Nate, there are a couple of questions already. Are you ready to field them?
I can try.
All right. So Granite Penguin asks, where is image management done and where are the images stored?
So the images so the management itself would be done however you choose to manage container-like images, right? So if you've already got this cool CI/CD pipeline that you're using to build container images with, you can actually drop image mode images right in that same pipeline. Now, in my experience, there were a few little snags that I had to get around just because of the way RHEL is managed versus the way a container is managed. And there's, of course, some slight differences in how a container file gets written, although they're largely identical. But there's different ideas, different paradigms you need to put in place because you're doing things like you don't have to register a container, but you have to register a RHEL image mode system, right? And there's ways to do that in that build pipeline. And then where do the images get stored? Well, you might see this coming, but they get stored in a container registry the same as you would any other container image. And that's exactly what we did. Sorry, go ahead.
So I think what Granite Penguin was getting to is like when we did the Bootsy download of the new image, where did that go?
Oh, that went to basically it went to the file system of the system that we're running on, right? So the system we applied the update to, the file system tree gets written out, and like I said, it's like a dual tree mechanism, like you'd see with RPM OS tree, for example, or some other like edge device use cases where they had that two different tree mechanisms. Um, it writes out a new tree with all of the stuff that was in the container file or in the container image. Of course, merging etc and not replacing var, like I said earlier. And then when you reboot, all it says is switch those trees.
So it's essentially like A/B imaging, right? Where you
Right.
pull down your
Right.
B image, you switch to it, and then later on you can replace your A image with whatever the next image after that is, right?
Right.
And you just kind of oscillate between the two. But Nate, I cut you off. You were mentioning container registry, which I think is actually a really cool management thing.
Mm-hmm.
Can you finish your thought on that?
Sure. I mean, that was kind of the end of the thought, but they're stored in a container registry like you would any other container, which means you can do things like apply tags to them, say these are my dev and these are my stage and these are my prod systems. Or you can apply date stamps, for example, like this is when we applied our Q2 patches and these are our Q3 patches. And of course, they respect the same latest tag like you would with any other container image. So you can just say, I want this machine to track whatever the latest is. And whenever it gets updates, right?
And that's actually what you're doing when you did that Bootsy check at the very beginning, and it said you had an updated image. You were checking the registry,
Yep.
which said you had a newer container available,
Right.
and showed you what was there. The other really cool thing about registry is, well, first let me say you will be storing containers essentially in your registry that are multiple gigs in size, right? Because they're the entire
Yeah.
operating system image. But you know, if you've worked with virtual machines in the past, trying to get new images can be problematic, especially across things like implementations or
Mm-hmm.
subsystems or clusters or like however you have it organized. But container registries are pretty well understood of like how you configure your machine, and then you just pull a updated container out of a registry, and you can do that regardless of things like cluster or storage backend or like all these other things. So from a how do I get this machine to another developer or another environment, all of a sudden those questions become a lot
Yeah.
easier.
And the really neat thing is, I built this specific use case. The developer has pushed updates to the registry. That developer may not have been developing against a physical machine. You can actually run these things inside of Podman on your local desktop. So if you make changes to it, now obviously it's not going to do the full bootable mechanisms inside of Podman, but you could test to see if the container comes up. You can test to see if your changes worked right inside of like Podman desktop or direct Podman on your laptop, right? Which I think is also a really cool thing. Which previously we've done with like what was that? Vagrant, I think, was the thing that would let you spin up and spin down systems locally so that you can do some testing before it goes onto actual physical machines or actually into the actual infrastructure. This is kind of like that, except I think simpler, easier to deal with.
Yeah, and so on that note, like one of the things that we're trying to do with the design of Bootsy and image mode based images is you've got it in your registry, and if you pull it into a container tool like Podman or Podman Desktop, it works like a container. And if you instead deploy it on a virtual machine or bare metal, it works like an operating system image. The
Right.
container side piece, like you pull it into your container applications or container management, whatever's, the kernel and all those files are still there in its file system, but it's not being run, right? It's just using the application layer stuff. Whereas if
Right.
you put it on a virtual machine or bare metal, it's got to boot into the kernel and have all those other mechanics of a system, and those are already present in the image, and now they can be used on that bare metal or virtual machine.
Right.
Um,
There was a very nice leading question in the chat just a second ago from Granite Penguin. Does this work to do major release changes? And this is what I was hinting at earlier during the critical path. And the answer is it can. You can do a bootc switch, which is a command we're not going to touch on today, but it's basically how you tell it to switch to a different container image, maybe even from a whole different registry. And you can do a bootc switch between a RHEL 9 image mode system and a RHEL 10 image mode image. Now, obviously, all the caveats apply about moving major operating system versions, right? If there's library differences or whatever that your application depends on, that stuff you're going to have to test before you switch. But presumably, you did all that before you pushed it to your registry and were ready for the move. But yes, you can move from 9 to 10, for example, using bootc switch.
But I would go even a step further and say that it's actually safer to do it this way, because when we use tools like Leap and it's doing individual RPM upgrades, there's really not a way to downgrade yourself back to the old version again. Whereas with Bootsy, you simply tell it to boot the previous image and reboot. And now you're back to your RHEL 9 image that you had initially. And we actually have a little like quick walkthrough of this. And I can share it in the chat.
Oh, the demo, right? Yeah. Cool. So I do have more to show. We have any other questions that I missed that maybe we want to talk about?
I think we covered. So somebody asked about, can it be done bare metal? I think we covered that. Ness D said that was asking about compression, a variety of other things for edge computing use cases. So the actual thing that's making the bootc and image mode image is RPM OS tree, which is the same thing that we've been using for RHEL for the edge. The big difference between them is while the file system and like image management kind of works in a similar way, RHEL for the edge also has some automated validation testing at boot time and will automatically switch you back if there's a failure, as well as a bunch of technology to do image transfer with like intermittently connected systems or like, you know, that kind of stuff that's not currently present in just image mode, right, natively. So there are these like additional technologies that are included in edge deployments that are not just native to image mode of Bootsy, but are included in some additional Red Hat products designed for edge use cases. But yeah, I think that's about it.
All right, let me get my next share set up here because I got to switch to another system so it's nice and clean. All right, so I wanted to take you through the whole process that got us to the point where I started the critical path at, because I thought it'd be useful for people to see, like, how do I actually build an image and how do I maybe make a VM out of that image, which is exactly what there's a public lab, which I'm going to base this on, and you're going to see some of the instructions because I have to grab some commands out of the instructions as I pull them out. But there's a public lab where you can go try this on lab.redhat.com. So feel free to check it out if you want to get your hands on this yourself and poke around at image mode. So first of all, we talked about a container file, and I wanted to show you how much we meant that. So there's a container file here, which is going to look very, very similar to how you build a container file for any other container, right? We've got a from line here. In this case, we're basing it on the registry.redhat.io RHEL 10 RHEL bootc 10 image. Now, this is where one of those snags that hit me when I was trying to do the CI/CD stuff. If you're building this on a registered RHEL system, this will work just fine. You'll be able to pull that in. All you have to do is authenticate to the registry. Updates and stuff are going to work because they inherit all that from the host you're building it on, right? So entitlements and whatever. If you're building, in my case, I was building inside of GitLab. My GitLab runner is not a RHEL system. It is a Podman container that runs UBI. So there's no registration involved. Because it wasn't registered, it couldn't get any updates. So you have to actually like register and subscribe that build host so that it can build so it can inherit that entitlement. So just a thing to keep in mind. You can see here that this is adding in an Etsy directory and putting inside of /Etsy. Now this is like basic configurations that are included in the lab, right? So, but this is an example to show you how easy it is to add in. This is a whole directory structure. And what that'll do is, like I said, it'll merge it with the Etsy directory inside of the image and on the host once it's deployed. And then we're doing a DNF install and we're enabling HTTPD. Now, obviously, you can do a lot more. You might notice that we don't have things like the entry point or the CMD that you would normally find at the end of a container file, because this is a general, it's going to build and run a general purpose system. It's a system that runs init. So you're not going to tell it what to run. You tell systemd what to run, right? And then the init system will take over when the system boots up for the first time. Similar to that UBI init container that we showed, I don't know, two months ago or whatever. All right, and that's our basic container file. So what we're going to do now is I'm going to go ahead and build a container from this this image, and this is where I'm going to cheat a little bit because the command I need is right there in the instructions, and why not use it? All right, so you can see it running through. This feels a whole lot like a container build. Anyone who's ever built a container, pretty much ever, should recognize what this is doing. All right, you can see there it's running that systemctl command. So it runs Apache, it's at boot. And then it tagged it just like you would any other container. Let me clear the screen here. Now, I wanted to show you a couple of things. Actually, here, let's push it to the container registry because that takes a second. Also got a podman push to run here to do that. And you can see this, there's a lot of layers here, right? A lot of steps. There's a lot of data that it's pushing up to this registry. So if you're on, a slower connection, this will take a while. This is local within the lab environment, so it's pretty quick. Okay, now let's do. So before we started, I pulled in a RHEL 10 UBI image, right? And that's right here. And then we just built this new RHEL Bootsy image right here. So you can see the size difference. This says RHEL 10 UBI is 216 meg. RHEL, the image that we just built, which is full RHEL, right? 1.5 gigabytes, right? So you can see where these images are a lot heavier, right? So that is another thing you may want to consider, depending on where you're hosting your registry or how you're hosting it. These are going to be much larger images, so you might want to plan for things like disk storage, or if you're using some third party that charges you based on size or transfer, that's stuff you're going to want to think about before you start pushing Bootsy images up to your registry. Okay, but the next thing I wanted to do, and I think, let me see if it's in here or if it's on the next step. I think it's on the next step. Just a second here. So we push that up to the registry. Sorry, because the way this lab environment is designed, I had to keep that tab open until I got through those commands. All right, now we're going to actually tell, there's a special container image which will build a virtual disk image out of that container. Now, you don't have to do this if you're not specifically doing what I'm about to do next. What I'm going to do is I'm going to run a local VM on this system inside of libvirt, and that needs a disk image to do it. There's other ways you can deploy these things. I know Scott said at the beginning that you won't be using Kickstart. There's a way to leverage Kickstart to deploy these things, right? So for that initial build, you might do that. You can build an ISO file to install from, or like I said, you can spit out a virtual disk image, and that's exactly what this is doing here. Yeah, this takes a little bit of time because it's basically pulling down that image from the registry, and then it's converting it into an actual virtual machine. Now, in my home lab, one of the reasons I was poking around with the CI/CD stuff, what I have is a script that will run this container. It'll run this conversion container based on the image that's in my local registry, and then it'll deploy me a VM, right, just by running one single command, right? So I have CI/CD automation that'll build the image, and I can kick that off whenever I want to. Or, you could build up some kind of automation that says run this once a week or run this once a quarter or whatever. And you can have things in there that'll do things like apply operating system updates. But the point is that when I build a new VM now in my home lab, if it's image mode related, it pulls the latest container image from my container registry, builds a virtual disk image out of it, and then stands up a new VM using that virtual disk image. So every time I deploy a new system, it's always based on the latest and greatest image in my registry. So are there any questions we can answer while we're waiting for this to run? It's going to take another minute or two.
Actually, Granite Penguin asked, are there obvious markers inside of a system that would tell you whether it's a Bootsy system versus, or image mode system versus a package mode system? So if he was like to have his team look at a system that maybe they're not familiar with, how could they tell whether they need to use DNF update or Bootsy to update?
Yeah, I think the easiest way is the Bootsy command line tool, right? On a package mode system, it may not even be installed, but if it is installed, you can ask it, are you booted from an image or not? And it'll tell you, yes, I am, or no, I'm not. And I think actually, I forget if it's on this page or not, there was an example of that in this lab.
You're talking about Bootsy status?
Yeah, there's a section inside of Bootsy status that says booted, and it'll say 0 or 1, I think. I forget exactly what the output looks like. But we'll look at Bootsy status once we get our system up and running, and you'll be able to see that. Okay, so now we have the image kicked out the other side. I think the next thing is to simply copy the image over to the location where images have to live on a libvirt system. Now we're going to run virt install to actually make a VM out of this thing. And now, like I said, this is specific to this environment. If you're running these things on a cloud provider or something else, then you may not go through these steps. But okay, now we're going to run our VM, and this will actually boot up a VM that's based on that image that we just made. And now at this point, we just have to wait for it to finish booting. It'll be over in this other tab once we get to it. There was another thought that I had that just left my brain, but sorry.
And so, Nate, you actually showed like a combination of two things. One was building the image.
Mm-hmm.
And then the other is once you had the image and it was in the repository, you then started doing local hypervisory things to create a virtual machine instance to consume and boot that image, which like that's where you're saying like if you're a cloud provider, you wouldn't do things like a virt install. You would do cloud provider things. Or if you're a VMware person, you would do VMware things.
Or like I said, you could output that to an ISO file. And I think that conversion tool that I just used will do those things for you. I just haven't tried them myself because the thing I cared about was building a virtual disk image, which is exactly what we did there. All right, this thing should be up by now. Let's refresh the screen. Now, when we built it using that container, the image builder container, we had injected some authentication information into, I think, using Cloud Init, so that it has a local user inside of the image to start with. There's not going to be one baked in otherwise, so you have to do something to get a user in there. So just keep that in mind. Okay, so here we are. We've got our system up and running, and you can see this particular one is not connected to Insights, but it can be. That's another good point. You can still register these things with Insights. There's tooling that's being integrated into Satellite as well to manage these container images and to manage image mode systems. So you're definitely not left in the dark when it comes to those things. But obviously, the whole mechanism, like everything that you would do to manage an image mode system, in a lot of cases is different. So there's work being done on some of that tooling. All right, so let's clear the screen here, and then let me get Okay, so let's see. Remember, we installed Apache during that that container file, and we told it to enable it. Now we can see that did work. In fact, right? We have a system up and running, and it has HTTPD up and running, and it did install it and all that stuff. Now we could have gone further to say things like copy in our web tree, or install these dependencies so that we can then pull in our application later using some other automation. That's another question we get a lot. Does this mean that I no longer need Ansible? Because a lot of people would be deploying a clean operating system and then coming back in with Ansible to do all the configuration. Now you can do all that stuff inside of the container file. Well, my answer to that is no. There's still lots of things that you can do to manage your image mode systems using Ansible. So no, you don't have to get rid of Ansible in order to do this. Okay. So the next thing we can do is we can actually try to push a new version of our image back into that registry. So let's go back over to the terminal here, and let's clear the screen so you guys can see better. Let's go back into that container file. Now, like I said, what this will do is it bases it on this image, and then it adds a couple things, and then we're done. Well, what if what we want instead is every time this image gets built, it makes sure that the system is up to date, right? It makes sure that the image has the latest and greatest package set on it. So we can just add a run in here that says DNF, no, update -y. And what that'll do, of course, is it'll now do DNF updates before it does the install of the HTTPD package. Okay. Now, if we go back to our podman build command and we run it again, what it should do is it'll see that the bulk of this image is the same. It's not going to change that, but it realizes that we added a new command to that container file, and it applies that. It did some updates. You see there the things that it updated. And now everything after that line, it's going to run again. So it's going to do the install of Apache, and it's going to enable the service and all that. And this is the way I built my container file, because every time I run the CI/CD, I want it to spit out the most up-to-date image that is available to me at the time. All right.
NestD asked in chat that leaning into the update it like a smartphone, over-the-air updates and that kind of stuff. So what we're showing you is just normal networking things. So if you have 5G modems that work on your systems, then you could use those 5G modems for transferring the images and applying them and booting to them. I think where things get a little bit more interesting is if, like, for example, you're a cruise ship and you need to push out updates from corporate to the cruise ship, and the cruise ship sails away from port mid-download. What happens when it pulls into the next port, right? So with image mode, just the tooling that we have here, you would need to re-kick off that download and try to re-pull the image to the system. There's another product from Red Hat called RHEL for the Edge, and RHEL for the Edge has a whole bunch of intermittent connectivity assessment, like reconciliation. So that may be a better match for certain things. Behind the scenes, it's also using RPM OS tree and the alternate build trees, like or file system trees, like what Nate has been talking about with image mode. So a lot of the core technological components are shared between the two things. You build RHEL for the Edge images a little bit differently currently, although I know that they're working on changing that so that image mode and RHEL for the Edge are built in the same way. And then RHEL for the Edge comes with all these additional validation and other stuff due to the weirdnesses of Edge. that we don't account for with regular image mode, because we're assuming that you have a computer and you know how to manage the computer and you have networking and other stuff that is infrastructure.
All right, so all I did while Scott was talking was do the push, and what that did is it took the new version of the image and pushed it into the registry that we have locally here. And now we can switch back over to our actual image mode system. And this is where we're going to start playing around with that Bootsy status that Scott was talking about earlier. Now, to save myself some typing, I'm just going to become root. So first of all, let's do, yeah. I'm doing this format equals YAML only because it comes out, I think, a little easier to step through. So what we get here is this YAML output of kind of the status of our Bootsy system, right? And we can see here the spec. This tells us what image it's currently running right now, where it got it from, registry, right? Tells us that the boot order is currently the default. I think if we do a rollback, it changes the boot order to rollback. We can look at that once we try to do another rollback. I don't think we're doing another rollback. We can look anyway. This tells us whether there's another image staged or not. So you can see here, it says staged, and it tells us there's nothing staged, right? So that's just means that we're good. Booted, it tells us what image that we're booted from. And this, I think, if you were to run Bootsy on a non-Bootsy built system, this is where you would see those differences, right? There'd be nothing in here. It wouldn't say, hey, we've got an image that we're booted from or anything like that. Let's see, anything else good here? Rollback. This tells us whether there's a rollback queued or not, things like that. So, useful things. Now, remember, we pushed an upgrade. We pushed an updated container to our registry. So now if we do that, Bootsy, upgrade, that check again, it should tell us, yep, there's totally a new image that we can get as an upgrade, right? So if I did that upgrade again without the check, now it'll pull down that image. And now this time we're going to take a little bit of time and we're going to look at the Bootsy status after we've pulled in that image. Things I've done while waiting for computers.
Yeah, we should have queued up some questions.
Yeah, that would have been helpful.
Or we could just sit in silence and say nothing.
Because that makes engaging stream content.
That's right. Well, while we were starting this, one of our viewers remarked that it was a live demo.
Mm-hmm.
Nate, how do we feel about live demos here at Into the Terminal?
They are exhilarating, and what could go wrong?
But also, that's all we do.
That is all we do. Everything we do is live. I don't think we've ever done a pre-recorded demo on this show.
Yeah. Well, there are a couple times where, like, live demos do sometimes come off the rails, and that happens sometimes. But thankfully, I think that's relatively infrequent for us.
Yeah, well, today I was having trouble getting this lab to provision for me. So, like, I did all my test and prep this morning, and then when it came time for showtime, I'm like, okay, let's nuke them and start new ones because I want them fresh for the demo, and they wouldn't provision. That's why we were a little bit late. I eventually got them to provision though. Okay, so we've now staged that upgrade. Let's clear the screen here and we'll do that Bootsy status again. In fact, Bootsy status is kind of neat. If you do the dash format, and there's a couple formats you can bring it out in, it'll give you all the data. But if you take off the format, it'll give you relevant information, which I think is kind of useful, right? So if I had done this before I had staged that upgrade, it would have just said, here's the booted image. But now that I've staged something, it tells me there's a staged image. If I have a rollback queued up, it'll tell me there's a rollback queued up, right? So I think that's handy, but if you ever need the full output, you just do that extended output there, and it'll give you everything. All right, so we queued the upgrade. Let's reboot and see if our upgrade works. Now, again, this takes a second, rebooting a machine, But yeah, I've had lots of fun conversations with folks around image mode, and just kind of the ideas that people start having once they understand what this does and how this works and what options it opens up for you. It's really neat when when you see someone's like, "Wait, I can do that with this?" Yes, you can. Okay.
And we've actually had like a whole bunch. We've actually been working on this for 15 years, I think.
Yeah. Just like incremental things that have gotten us to this point.
Yeah, because like we have CoreOS, right, which is a immutable operating system that you update as an image. We did RHEL Atomic, which was similar, but the problem was you got a built image from Red Hat, and then you couldn't put anything in it. So that like
Right.
made it very appetizing. It was supposed to be more like a RHEL appliance, but when you needed rando Python library, there was no way to get it in the image. And
Right.
so we tackled some of that with RPM OS tree and RHEL for the edge. And then we moved into like, okay, we're going to build it using container files, which now means we can do things like apply all of our container management techniques.
Mm-hmm.
Yes. Instead of doing, having to create our own tooling, or like Nesty was asking about compression and layers, and like, no, the containery things do all that. Like we don't need to figure that out.
Yeah.
Containers have figured that out for us.
Because there's solved problems in the container world already. Now, that could mean, because of the size of these images, that might mean there's room for improvements there. And I think I heard somebody that's related to this telling me that there's work being done for improvements there. But yeah, so more to come, I suppose. All right, so we've rebooted, and now you can see it is up and running on our latest container. I don't really have a quick and easy way to show you that, other than that now it's up to date. I guess if I did there shouldn't be any updates waiting for it now, because we just pulled them. Oh, we can't because it isn't registered. Never mind. So anyway, now, see, we had a question about Bootsy status, right?
Yep. And then while you're pulling that up, we also get weird questions like, cool, I have a Bootsy image. Yay, go me. Now I want to do a DNF update. It's like, no,
Right.
no.
Yeah.
You are either living the image lifestyle,
Yeah.
you're living the RPM lifestyle. And
Right.
we don't cross the streams. You either choose to go with this. So like, oh, there's a new CVE that came out. What do we do? Well, instead of doing DNF update on a package to close and mitigate that CVE, you instead build a new Bootsy image, send it to your repository, check it out and apply it to your machines, and then boot into it. And now the CVE is mitigated in your new system.
Yeah, I mean, not just a new image, just an updated image, right? All you're doing is you take your container file, you add in the thing that's going to fix that problem, or maybe in the case where the example I'm running here, where it just has a DNF update built in, maybe you just tell it to build and it gets all the updates, and now that CVE is fixed. The other really cool thing that I've talked through with a couple of customers, and this is one of those aha moments. Let's say the image I'm booted from right now, this is built to my corporate standards, right? But now every environment has these, right? You've got, okay, I've got my corporate standard build, but now I need my corporate standard build as a database server, or now I need my corporate standard build as a web server, or now I need my corporate standard build as a shell server, right? The cool thing about this, about the way this works, is if I go, let's see if I can do this quickly. If I go and take this image, right, because that's in my registry. Oops, too many capital letters. If I go back to my container file, and instead of being from the upstream, let's just comment that out for now. Another from line. Make it from, and we're going off script here. So if something goes horribly wrong,
We've
and
known
now
it.
let's say like also install, I don't know, MariaDB-server. I'm going off the top of my head here as to what the name of that package is.
I think that's correct.
Right. So now we're going to say, take that corporate standard build and apply MariaDB to it. And then we're going to go back to the Podman build, and this time we're going to call it, I don't know, test Bootsy MariaDB. And what this is going to do is it's going to build another container image, another bootable container image, and it's going to add in those things that I did. It's going to add in that MariaDB installation.
So my solution to that problem would have been slightly different, Nate. I would have said, build a MariaDB container and run that on top of your Imageoid image.
You could do that. You could.
You can now like manage your operating system updates and your application updates separately because you've divorced them, having essentially two images for them.
So here's the neat thing. Now, if I make changes to the corporate standard build base image there, then all I have to do is kick off image rebuilds of all of my sub images, and they will inherit that, right? So if I fix a CVE at the top level, and then, you know, I've now scheduled maintenance windows for all of my applications that need to be rebooted to bring in the change. All I have to do is between then and when the reboots are supposed to happen is make sure I've told my CI/CD pipelines or whatever to rebuild all of those sub images, all those images that are based on it, and they'll pull in all the updates, right? This is like usual container workflows. You're right, though. You could run it inside of a container on top of the image mode host. So that could be another option. All right, so now I have to do a push. I call it Bootsy-MariaDB, right? And that should push that new image up. And then I should be able to do a Bootsy switch on the other system over here. I just need this to do that with. If I did, and again, off script here, I didn't look up the syntax for Bootsy switch. I think it's just this. Right? So now I'm going to tell it, switch the container that we're running to that MariaDB container.
And actually, before you do this, the reboot, why don't you do a Bootsy status so we can see the,
sure,
this is what's staged.
Okay, now if we do, let's clear the screen, sudo Bootsy status. Now it tells us not only is there a booted image, there's a rollback image, because remember we already did updates to this thing once, and there's a staged image. So now if I just reboot the system, let's just do reboot, just less typing.
Oh, now the real trick is, did we get all the run commands right to actually start on MariaDB automatically on boot?
We'll see. I may have done enough MariaDB builds that I got them out of memory. I'm not sure. Probably being too impatient here. Yeah. Give it a minute. Oh, there it is. Oh, MariaDB's failed. Oh, well, we haven't configured it or anything. So, but it did try to start it. Yeah, it failed to start. Directory var log MariaDB does not exist. Okay, so that's, yeah. We needed to do more to make sure that MariaDB would come up. And that's probably because var already existed. And like we said before, var does not get overwritten with a new container deployment, with the new image deployment. So because varlog MariaDB did not exist when we built the initial container, then it didn't get created when we pulled in the new image. So that's probably why that failed. Does that make sense? Am I just speaking weirdness here?
Could you just do an mkdir varlog MariaDB? Although it's probably going to like send us down a trail of a lot of things aren't there. Yeah, it's going to send us down a trail.
There's something else, I'm sure.
What else we got?
That's actually the end of my demo. I just figured we could poke around. If we wanted to look at the CI/CD stuff that I built, we can, but we're already at an hour, so I don't know. We did start a few minutes late.
Yeah, maybe another episode on image mode where we could talk about like building CI/CD pipelines to manage it would be cool.
Right? We could probably do that.
If you've made it this far, don't forget to like. And if you're interested,
yeah, I mean, you've already watched us for an hour. You must like the content. You should click the button.
So next week, Nate, you're on your own.
Yeah, I don't know. I don't know what we're going to talk about yet, but maybe I'll give you a crash course in CI/CD pipelines for image mode. I don't know.
So join Nate next week. I will be living in a tent in the mountains for a week, tending to small people, running around and doing stuff.
Sounds like fun.
You know, for varying descriptions of fun. But I will be back the week after that, and we'll do something in a couple of weeks with me. But you'll see Nate on his own next week under the terminal, Fridays, noon Eastern.
Maybe I'll convince Mycene to come along because he's the image mode guy, or Ben Briard with his glasses.
Mycene has a whole like GitOps thing done for image mode. Like he's got the workflows.
He does. He was the guy that I talked to mostly to figure out how to get mine working. So he'd be a good one to bring along.
Well, thanks for joining us this time. We will see you next time on Into the Terminal. Bye, everybody.
Have a great one.